Topic 4, homework problem number 10. We want to minimize this problem here, minimize the function s. I want to substitute the y here so it'll be made out of only one variable. So here I have xy equals 18, and I solve for y. I'll get y equals 18 over x. By the way, when we solve, this means we want to solve for positive x and y's. Okay, so here's my substitution. All the y's will become 18 over x. So this now becomes s equals x plus 18 times 18 over x. This now becomes x plus, see, 18 times 18 all over x. I'll find out what 18 squared is soon. Okay. Now to minimize this, I want to take the derivative of s. So let's treat this as s equals x plus 18 squared times x to the negative 1. So the derivative of s will be 1 plus negative 1 times 18 squared, which is negative 18 squared. And this will be x to the negative second power. Now I'll set this equal to 0. I have 1 minus 18 squared all over x squared. And I'll solve for x. Here I'll multiply both sides by x squared, giving me 0 equals x squared minus 18 squared. Okay, now this is the difference of two squares, so I'll get 0 equals x plus 18 and x minus 18. And when I solve these for x, I'll get x equals negative 18 and x equals positive 18. But remember, we were told that x and y must be greater than 0. So I'm going to use that x is equal to 18. So this will give me y equals 18 over 18, which is y is 1. So now that I know that y is 1 and x is 18, I can replace those values. Let's go back here and replace those values for s. So the minimum value for s will be x is 18 plus 18 times 1 for y, and 18 plus 18 will give me 36. So 36 is the minimum value. We'll look for the minimum value again for this function f, and I'm going to use substitution. I'm going to solve for my x. This implies x equals 5 minus 2y. So I'll replace this x here with the 5 minus 2y. So we have f equals 5 minus 2y squared plus y squared. Okay, I'm going to expand this using binomial expansion, which will get a squared minus 2ab plus b squared. So this is my a. So a squared will be 25. Then minus 2 times ab. This is a and this is b. So multiply these, you get 10y. Multiply that by 2, we get 20y. And then plus b squared, which will be plus 4y squared. Then we'll add y squared. Okay. I'm going to put this in order and click like terms. So we'll get 5y squared minus 20y plus 25. Okay, now I'm going to take a derivative of this function, and we'll get 10y minus 20. Then I'll set this equal to 0 and solve for y. I'll get 10y equals 20, and this implies y is 2. Okay, y being 2 implies that x equals 5 minus 2 times 2, which is 5 minus 4, here this gives us that x is 1. So we have y is 2 and x is 1. So the minimum value will be f equals x squared, which is 1 squared, plus y squared, which is 2 squared, which ends up being 1 plus 4, and the minimum value for the function f is 5. Topic 4 homework, problems number 20 and 21. The radius of a circular puddle grows at a rate of 10 centimeters per second. We want to find the rate of growth of the area when the radius reaches 20 centimeters and when the area reaches 1 centimeter squared. The radius of a puddle that grows, basically we're looking at a circle here, and it's growing, so it's going from this size to this next size. Now, the radius is growing, so let's draw the radius. So here's the radius. The radius is going from that spot and traveling to this spot right here. So it's traveling from here to here. And we're told that it's traveling 10 centimeters, and a centimeter is about that long. It's traveling 10 of those right there every second. We want to find the rate of growth of the area. Well, area is measured by finding out how many of these little squares are in something. So how many squares are we getting from this size to this size? A square is measured as centimeters squared. And we want to know how many of these we're getting per second. At the exact point that r is 20 centimeters. So when r right here becomes 20 centimeters, we want to know how many of these little squares we're getting per second. Okay, so I need a formula that relates area and the radius. So I have the area formula for a circle, which relates the area and the radius. So pi equals a equals pi r squared. Now, I want to take a derivative of this, and since everything's being measured in seconds, my derivative is going to be with respect to t, or time. So let's take a derivative of this with respect to time. So I'm taking a derivative with respect to time of a. A does not match t, so I have to use the chain rule. So the derivative of a is 1. And then the chain rule, because these are not the same, will be dA over dt. Now, next, the derivative of r. R, again, is not t, or this is not in terms of t, so I have to use the chain rule again. So this will be 2 pi, then times r, that's the derivative, and then times the chain rule, which is dr over dt. Okay, now, this right here is the change of area per time, and that's what we're looking for, change of area per time. This here is the change of radius per time, and that we do have. Here's the change of radius per time. And let's put everything in. So we're looking for my dA over dt, 20 pi. The r, we're told, is at 20 centimeters. And the rate of change for the r per time is 10. Okay, so let's put all that together, d over dt. We have basically 40 times 10, which is 400 times pi. Now pi, we typically take that at 3.14. So 3.14, and we'll multiply that times 400, and we'll get a dA over dt, the rate, will be 1,256, and this will be in centimeters squared, those little squares, every second. Okay, the next question is, well, what would the rate of the area growth be when the area equals 1? Well, to do that, this formula only works right here when we know the radius. Well, what would the radius be when the area is 1? Well, let's go back and figure that out. Since A equals pi r squared, and we know that the area will be 1, we can backtrack and find out what r squared would be. So 1 over pi would equal r squared, and the square root of 1 over pi would represent the radius at the place where the area is 1 centimeter squared. So now I'm going to use this problem again, and I'm going to now put in, instead of 20 for r, I'm going to put in square root of pi, square root of 1 over pi. So that'll be dA over dt equals 2 pi, and my new r is the square root of 1 over pi, and my rate is still 10 centimeters. Okay, so let's put all that together. Let's see, that'll be 20 pi times the square root of 1 over pi. Okay, let's put all that into the calculator. See what we get. 20 pi times 1 divided by the square root of pi. Let's see, there's my pi. Here we go. And I'll raise all that to the half power. Okay, and I get 35.45. 35.45. Okay, and again, this is area, so it's centimeters squared, and that's per time, which is measured right now in seconds. Okay, topic for homework number 26. We have an average cost function for CDs players, and it's 130,000 times x to the negative 1 power plus 30 plus 0.01x, and this is how many the cost per player, or the average cost per player. And we're told that there are 3,000 players and 100 players per week are being made, and we want to know what is our average cost at this. What is the average cost? What is happening to the average cost function at this point? So to find that out, we want to take a derivative of this function with respect to time to know what in the world is going on. Let's interpret these. 3,000 players. The x that's here is actually representing the players. So when they say 3,000 players here, that's simply a value of x. X is representing the C players. Here we have players per week. Players per week, that's a rate. The players, which is basically the x, and per week is a time measurement. So this is really a change of the players per change of the time. Okay. So this rate can be represented by dx over dt. So very important to kind of figure out how these are labeled. Then let's go ahead and take a derivative of this. We have the average cost function equaling 13, 0, 0, 0, 0, x negative 1 plus 30 plus 0.01x. I'm going to take a derivative of all of this with respect to time. Okay. Now, because this is with respect to time and this is a cost function, we'll have to use chain rule. So derivative of this is 1 times the chain rule, which will be d cost function over dt. Now, this is x, not a t, so the variables are different. So again, we'll have to use chain rule. So we'll take the derivative of this, so we'll be negative 3, 0, 0, 0, 0, x to the negative 2, then times chain rule will be the change of x over the change of t. The derivative of any constant is 0. And again, the derivative of this, I'm using chain rule, will be 1 times its value, so plus 0.01 and then chain rule will give us dx over dt. All right, furthermore, so we can find the change in the average cost function now with respect to time, given that we do have our x values here and we do have our change in players per time. So let's put those in there. So 1300, and the x will be 3000 to the negative second power. This right here will be 100 plus 0.01 times 100. Okay. All right. Let's go ahead and see what I can do on my own without using the calculator. I have a total of 1, 2, 3, 4, 5, 6 zeros here. 2, 3, 4, 5, 6. Okay, 6 zeros there. When I square this, I have a 9 and 6 zeros. A 9 and 6 zeros. Okay, and then when I multiply this, my decimal will move over twice and I'll get a 1. So this ends up being negative 13 over 9 plus a 1. A 1 is the same thing as 9 over 9. So we actually get a negative 4 over 9. And if I remember correctly, that's negative 0.44, repeating 4s. So about 44 cents on that one. Okay, topic 4, number 39. We're given a demand function and we're asked for the price of elasticity at $30. Well, to find the elasticity, we need to do a couple things. We need to take the derivative of the demand function and then divide that by the demand function itself and then multiply it times the price. Okay, so first we need the derivative of the demand function. The derivative here will be 2 times 424 minus p to the first power. Then the derivative of the inner function, and this is all over 150. Okay, so that's the derivative of q. In fact, this is a 1, that's a prime, so let's kind of change that direction there. And the derivative here will be 0 and negative 1, so all this is negative 1. And furthermore, we'll need the function q. So this is the function q right here. And since the function q will be in the denominator, we'll have a reciprocal. So that means all of this will go in the denominator and the 150 will go in the numerator. So we'll have 424 minus p squared. And the 150 will be in the numerator. Okay. And furthermore, we'll have times p. So we'll put a p here. Okay. Now we can clean this up a little bit. Let's see. The 150s will cancel, leaving the 2 here. Let's see. And what we'll have left is this factor will cancel out with one of these factors. And so we'll have 1 left there. 424 minus p. And what's left? That negative is left and the p. So let's make it negative 2p. Okay, now we know that the price is $30, so we put $30 in here. So negative 2 times $30, all over 424 minus $30. And let's see what we'll get. This will be 394 all over negatives. Sorry, all under negative 60. And let's go ahead and work that out. 394. Okay, and that'll be 15 cents, about a loss of 15 cents. Well, it should be positive here. Let's see, where did I lose a negative? Oh, I lost a negative early on. I never included the negative in the whole problem altogether. So negative there, that makes that positive. And this will be a positive 15 cents. Okay, now the price to maximize the revenue. The price to maximize the revenue is basically taking this function and setting it equal to 1. So negative Q prime over Q times P equals 1. Okay, so essentially I'll be taking the result of this right here and setting it equal to 1. I have the results right there. So this implies 2p all over 424 minus p, all of this sets equal to 1, and solving for p will give me my maximum price that will maximize my revenue. Okay, so if I multiply both sides by 424 minus p, this implies we get 2p equals 424 minus p. Add p to both sides, this gives me 3p equals 424. Divide both sides by 3. And what I get is 3 goes into 4 one time, leaving 12, which goes into 4 times. 3 goes into 4 one time. After that I have a third left over. I'm going to round it up to simply the whole number, so I have 141. And that'll be the price. Well, let's put the change in there, the 33 cents. And that'll be the price that will maximize the revenue. Now the last question is, what is the maximum revenue? Well, we'll need the revenue function. The revenue function is basically taking the demand function and multiplying it times the price, or current price. Well, the demand function is right here, which is 424 minus p, all squared, all divided by 150, and then times p, which is the price. Okay.
Hola.
Yeah, give me 1 minute.
Oh,
Okay.
okay.
Now that we have the demand function times the price, I'm going to now put in the price that we found, which is the 141 and 33 cents. So 424 minus 141 and 33 cents, all squared, all over 150, and then times the price of 141, 33 cents. All right, and let's see what that is. Let's see. 424 minus 141.33. Okay, I want to square that. And then divide that by 150. And then multiply that by 141.33. Okay, and I'm coming out with a revenue of $75,283.97. That's the max revenue.